Objective 9, know why transition metals don't form true noble gas configurations and be able to draw the configuration for an ion of a transition metal given its oxidation number. So I don't want to make too big a deal of this, but transition metals are a little bit weird because when you look at them, if we do the configuration first, it's actually easier to then answer the question above. If I write the configuration for iron 2 or iron 3, let me start by writing the configuration for iron. If you find on your periodic table, it's number 26, and it's in period 4. So just plain old iron atom is going to be argon, and then it's going to fill up the 4s2, and then it's going to have to start filling up the 3d, and it's going to fill up 1, 2, 3, 4, 5, 6 of them in the d. So that's what iron atom looks like. So then, how many valence electrons does an iron atom have? If you look at that, how many of those are valence electrons? Just 2, just the 4s. Because the 3d6, those aren't valence electrons. Those are on the floor before. So when we talk about 8 is great and that atoms want to have 8 valence electrons like noble gases, that means we want them to have S2 and P6 filled up, because 2 plus 6 is the 8. So the D really doesn't matter. So now when I go down here, if I draw the configuration for iron when it loses 2, if it loses 2 electrons, which 2 is it going to lose? The 2 valence. Those are the easiest ones to lose. Least energy. It's all about energy. So boom, those 2 are gone. And now it has this 2 minus charge on it. That's what iron 2 looks like. But it's still got the 3d6. So that's why we say it doesn't look like a true noble gas, because noble gases, we don't usually see the d orbital. The d orbital is from the floor before, but now when metals lose electrons, now also we got those d ones around. They're just like bonus electrons. They can use them if they want, but they don't have to. If they want to lose a few extras, they can. If it makes it easier to react with something, then maybe it loses 3 or 4. Or if it only wants to lose 1 electron, then it can move that extra s electron into the d orbital. So it just gives transition metals a lot more options, a lot of extra things it can do. So if I go down here, same thing. If I go ahead and if I bring it in, now if it's iron 3, it's going to lose these 2 electrons. Where's the 3rd electron have to come from? The d6, right? It's not going to go to argon because that's really stable. That's a good thing. So instead of d6, it's going to, one of those is going to get taken off, and now it's going to become a 3 minus ion. So the question asked up above, the objective said, know why they don't form true noble gas configurations? Because they are filling up the d orbital of the outer energy level. And I'll just add, and noble gases aren't. So noble gases are usually filling up the d orbital 1 level below. But because you're losing electrons and emptying the top floor, now all of a sudden you've got the d orbital being filled up on the top floor. It's